What if I told you an advanced computer exists that can solve a complex problem in 1 second, which would take today's average computer 1,000 years to solve? It may sound like science fiction, but this technology is already a reality. Imagine a world where medical research accelerates exponentially, climate models predict outcomes with unprecedented accuracy, and secure communication is virtually unbreakable. All of this and much more could become possible through the power of quantum computers. Quantum computers are said to be 100 million times more powerful than today's most powerful computer chip. In certain types of problems, especially those involving massive data sets and complex calculations, a quantum computer can be exponentially faster than a classical computer. A problem that might take a classical computer millions of years to solve could theoretically take a quantum computer just minutes or hours. Quantum computers could change our world in ways we can hardly imagine, but how exactly do they work? And how might they transform our lives? And could there be a darker, more dangerous side to this technology? Stick around, because by the end of this video, we'll uncover the full story. First, we'll explore the incredible potential of quantum computing, and then we'll dive into the deeper, more unsettling, and sinister side of quantum computing. We first need to look at how they differ from the computers we use today. Classical computers, like the ones in our laptops and smartphones, work with bits that represent either a 0 or a 1. But quantum computers use qubits, which can represent both 0 and 1 at the same time thanks to a phenomenon called superposition. In simple terms, this means quantum computers can process vast amounts of data simultaneously. Now, add another quantum property, entanglement, which lets qubits be linked in such a way that the state of one can depend on the state of another, even across large distances. Together, these properties mean that quantum computers have the potential to tackle problems that are practically impossible for classical computers to solve. So, how will quantum computers impact our world? Let's look at some areas where they could revolutionize society. Medicine and drug discovery. One of the biggest promises of quantum computing is in medicine and drug discovery. Finding new treatments is a lengthy and costly process, involving trial and error with thousands of molecules. But quantum computers could simulate molecular interactions at an atomic level, allowing scientists to model complex molecules and predict how drugs will interact with human proteins. This could lead to faster development of cures for diseases and even develop personalized medicine based on a person's DNA. Climate modeling and environmental protection. Quantum computers could also help us tackle climate change. Our planet's climate system is incredibly complex, and current computers struggle with accurate long-term modeling. Quantum computers could analyze massive amounts of environmental data to produce more reliable models, helping us predict extreme weather patterns, optimize energy use, and even design more sustainable materials. This technology could also possibly predict a tornado before it forms, or even provide early warning signs of a major earthquake. Cryptography and cybersecurity. Quantum computing could both challenge and enhance data security. Quantum computers could potentially break traditional encryption methods by quickly factoring large numbers, a task classical computers find almost impossible. But researchers are also working on quantum cryptography, which uses the principles of quantum mechanics to create encryption that could be unbreakable, ensuring secure communication in everything from finance to national security. Artificial intelligence and machine learning could experience major breakthroughs with quantum computing. Quantum algorithms could process and analyze vast datasets much faster than classical computers, allowing for more powerful AI models. This could improve everything from self-driving cars to AI-based diagnostics and healthcare. With quantum computing, we might see AI systems that are smarter, faster, and more capable of solving real-world problems. But there may be a darker side to quantum computers, as there are with our rapidly advancing AI technology. In the not-so-distant future, imagine that a powerful government decides to use quantum computing combined with advanced AI to monitor and control its citizens. This could lead to a totalitarian regime and dark times for its citizens. Here's how this scenario might unfold. Real-time mass surveillance. The government uses quantum-enhanced AI to analyze data from millions of interconnected devices, cameras, and sensors placed in public and private spaces. With the computational speed of quantum computers, the AI can analyze this vast amount of information almost instantaneously, identifying faces, tracking locations, and even predicting individuals' behaviors based on patterns. Unlike traditional surveillance systems, this quantum-powered AI can process petabytes of video footage, phone data, internet history, and personal records in real time. Cracking all encryption. Most modern encryption methods, like RSA, rely on the difficulty of factoring large numbers, a problem classical computers struggle with. Quantum computers, however, can break these encryption methods within minutes using Shor's algorithm. The government uses this capability to decrypt all secure communications, including those used by individuals, private companies, and even foreign governments. This creates an environment where privacy is virtually impossible, as any attempt to secure communication can be broken within seconds. Predictive policing. With AI capable of predicting individual behavior, the government enforces a policy of predictive policing. People are arrested or closely monitored based on the AI's predictions about their likelihood to commit a crime. The AI models, fed by quantum computing, analyze every aspect of an individual's life, such as social media posts, known associates, and even biometric data like heart rate and pupil dilation to assess their threat level. Innocent individuals are marked as potential criminals, eroding trust in the system and creating a chilling effect on personal freedom. Manipulation of reality. Artificial intelligence also leverages its knowledge to control information flow. By monitoring and editing all internet content in real time, it creates personalized news feeds for every citizen, shaping their worldview and preventing them from accessing any unapproved or opposing opinions. The AI even uses deepfake technology to generate fake news or images, effectively rewriting history and creating a narrative that serves the government's goals. If you've ever been on a social platform like Instagram, you know that this deepfake technology is already in its beginning stage. The government believes the AI's predictions are infallible, but because the AI learns from biased data and receives no feedback or critique, it becomes a closed loop of reinforced biases. Quantum-powered AI makes irreversible decisions based on flawed assumptions, with innocent people caught in the crossfire. Attempts to challenge the AI's decisions are suppressed, and citizens have no legal recourse, as the AI's analysis is taken as the ultimate truth. In this society, freedom is nearly extinguished. Quantum-powered AI surveillance creates a totalitarian regime that anticipates and suppresses opposition before it even happens, with the government's absolute control justified by the AI's perfect predictive ability. Citizens live in a constant state of fear and self-censorship, and the few who try to resist are quickly identified, arrested, or even re-educated to fit the system's expectations. This scenario illustrates how combining quantum computing with AI could lead to unprecedented levels of control if used unethically. While these technologies have incredible potential for good, like enhancing healthcare and solving complex global challenges, they also carry the risk of misuse in ways that can profoundly impact personal freedom and privacy. So, how long will it be before quantum computers are up and running in a way that can really impact our daily lives? We are still in the early stages of quantum computing, with only a few experimental systems functioning in specialized labs. Companies like IBM, Google, and a number of startups are making impressive strides, but we are still likely a decade or more away from seeing quantum computers with practical, real-world applications. One of the biggest challenges is maintaining the stability of qubits, the fundamental units of quantum information. Unlike classical bits, qubits are extremely sensitive to their environment and can easily lose their quantum state in a process called decoherence. To keep qubits stable, quantum computers need to operate at ultra-low temperatures close to absolute zero, specifically around -173 degrees Celsius or near 0 Kelvin. This requires elaborate cooling systems, often involving liquid helium, which adds complexity and cost to the technology. So, while quantum computers hold incredible potential, there are still technical hurdles to overcome. Experts estimate it could take anywhere from 10 to 20 years before we see quantum computing technology mature to the point where it has a broad impact. But make no mistake, progress is happening fast. Once these challenges are overcome, quantum computers could change everything. And this power comes with both remarkable possibilities and potentially dark consequences. Thanks so much for watching. If you found this video informative or entertaining, please give it a thumbs up and subscribe to support more content like this. Your support helps us keep creating new videos.